Okay, so we were introduced to transistors last lesson. So today what we're going to do is we're going to look at them in practice. So remember, transistors are basically fancy switches. So when they get a certain amount of voltage across them, they turn on. When they don't have the voltage across them, the required voltage, they turn off. Usually for an NPN it's 0.7 or around about then, and for a MOSFET it's about 1.8, but you will always be given the value that turns it on or off. So automatic light circuits, how does this work? So we've got a variable resistor, yeah, we've got a light dependent resistor there, and we've got our NPN transistor there. Okay, so what happens with this circuit is, if you shade it or you illuminate the LDR, the light dependent resistor, we know that if you increase the light, the resistance goes down. LURD, LURD, light up, resistance down. Okay, so when you shade the LDR with your hand, the resistance will increase. So when the LDR is shaded, its resistance increases. Okay, so when that resistance increases, it also increases the potential difference across it, because the bigger the resistance, the bigger the potential difference. So when the resistance of the LDR increases, the potential difference across it increases. This results in the potential at the base of the transistor, so remember it's this part here that we're looking at, rising above 0.7 volts. Therefore, the transistor switches on and the LED lights. So go through that again. So if we shade this LDR, its resistance increases. Because its resistance increases, the voltage across it increases. And as the voltage increases, it will eventually get to 0.7 volts. So the transistor will turn on, which will turn on the LED. So the above circuit can be used to indicate when the light level falls below a certain level. So if it gets dark enough, the LED will turn on. And the light level at which the transistor switches on, the LED, can be adjusted by altering the variable resistor. The transistor would be destroyed if too large a current flows through it. So to operate high current devices, we sometimes have to use a relay. Okay. So let's have a look at this circuit here. So this is the one that uses a relay. So basically we use remember, a relay uses a small current to switch on a bigger current. So for this one, we have got similar kind of setup. So when something's shaded, the resistance of this increases, so the voltage across it increases. So it eventually gets to a high enough voltage to turn this on, which then turns on the relay. And then when the relay turns on, that gets closed and the mains lamp turns on. So you could use that in sort of street lighting. When it gets dark enough, you can use the transistor to turn on a relay, which will then turn on the lights on the street. Okay, so that's if the light gets low enough. So we could use the same kind of principles, but instead of light getting low, we could talk about the temperature getting low. So this circuit will turn on a warning light when it gets too cold, so frosty. So what you do is you cool down the thermistor, and remember, TURD, temperature up, resistance down. So if temperature goes down, the resistance increases. So when the thermistor is cooled, its resistance increases. So obviously if something's resistance increases, the voltage across it increases. So when the resistance of the thermistor increases, the potential difference across it increases. So potential difference across this, remember, we're looking at this voltage. That's the voltage that's important about turning on the transistor. So if that voltage gets high enough, then the potential at the base of the transistor rises above 0.7 volts, transistor turns on, and the LED switches on. So that's if it gets cold enough, the resistance across the thermistor increases, potential difference across the thermistor increases, which then turns on the transistor, which turns on the LED. This one is kind of the opposite way around. So it's when something gets too hot. So you can see that one had a variable resistor at the top and a thermistor at the bottom. We've got the opposite way around here. So I've already written this in because it takes me forever to write anything with this pen. So what we have now, we still need to look at the thermistor, but we're still interested in the voltage across here. Okay, so temperature up, resistance down. So if the temperature rises, the resistance of the thermistor decreases. So that means the voltage across the thermistor decreases. So that must mean the voltage across the variable resistor increases. And then eventually the voltage across the variable resistor gets high enough that it'll switch on the transistor, and then the transistor will switch on and the motor will switch on, and that will power a fan, so it will cool it down. So if it gets too hot, then transistor turns on and turns on a motor of a fan. So feel free to pause this if you need to copy it up. I know I'm going through it quite quickly. And this one here, car courtesy light delay. So when you open the door in a car, the lights tend to go on, but they only go on for a certain amount of time and then they switch off after a certain amount of time. So remember when I said we were looking at a component called the capacitor, which is really good if you want something to be on for a certain amount of time. So what we've got here is we've got a capacitor and we've got a variable resistor. Okay, so how does this work? So remember capacitors, the charge across them increases, so the voltage across them increases with time. So at the very start, the resistance across the capacitor is really small, so the voltage across the capacitor is really small. So the voltage across the variable resistor is large and the transistor is on, so that bulb is on. It starts off on. As time passes though, the voltage across the capacitor increases. So the voltage across the variable resistor here starts to decrease, and it eventually gets small enough that the transistor will turn off and the light bulb will turn off. So in this case, the light bulb starts off on and turns off after a certain amount of time, depending on how big the capacitor is. So a couple more examples of time delay circuits. Remember, time delay, there's always a capacitor involved. So in this case, we have got two different time delay circuits, one with the variable resistor at the top and a capacitor at the bottom, and one the opposite way around. So with a time delay circuit, the top one, when the switch is closed, the voltage across the capacitor starts off at 0 and the transistor is off. When the switch is opened, the capacitor begins to charge and the voltage across it slowly rises. When the voltage between the base and the emitter of the transistor, so remember that's here, this voltage here, so the voltage across the capacitor, it will rise slowly and eventually it will rise above 0.7 volts. The transistor will switch on and the light will switch on. So this starts off and turns on. Pen wants to work. Turns So it starts off, turns on. Okay, and the length of the time delay is controlled by the resistance of R and the capacitance of C. So a bigger capacitor, remember, takes longer to charge, and a bigger resistor makes it slower to charge. So to increase the time delay, increase the resistance of the resistor or increase the capacitance of the capacitor. And as before, a relay could be used to switch on a higher power device such as a motor. Okay, so if we want it to start on and then switch off, we switch them round. So this one starts on and turns off. So When the switch is closed, the voltage across the capacitor is 0. And the voltage across the variable resistor is basically the supply voltage, so it's high. So remember, we're always looking at the voltage here. So at the start, that voltage across the variable resistor is high, the transistor is on, so the LED is on. As soon as that switch is opened, the capacitor begins to charge and the voltage across the capacitor rises. The voltage across the variable resistor, therefore, decreases. When the voltage between the base and the emitter of the transistor, so that's this voltage here, falls below 0.7 volts, the transistor switches off and the LED switches off. There we go. That's some applications of transistors.